Greetings. Today we're going to talk about a couple of ideas and have an example. So the two ideas that we're going to talk about first is the vertical alignment. As you think about teaching, especially if you're at a lower grade or you're in a subject where you know there's another topic above you that has to be understood from something that's more foundational, we need to make sure that we are building the proper foundation so that students are prepared as they move on. In elementary school, if students struggle with multiplication and they don't really get a foundation in that skill, they end up having struggles in division. And if they have struggle in division, then they're going to have struggles in dealing with fractions. And if they have struggles with fractions, then they are going to have difficulties in doing algebra. So these are things that must be thought about in a vertical alignment mentality, that I am building the foundation for the next step for student success. If a student is not successful with me, how are they going to make up for that loss in the next class or the next topic or in the next course? If they're not getting it now, who's going to help them build that foundation? You might have some students that are have enough self-motivation, enough self-awareness that they might identify what's missing and work towards filling that gap in some way. You might have some parents identify some of these gaps and get a tutor for their student or address something with the school and make some kind of effort to help the student along. But you're going to have probably the majority of those students that miss some step are going to be continuing to miss that step and struggle with the next. And eventually there's going to be a breakdown where the student has an issue with not being able to progress rapidly or at all. And so we need to be mindful of the vertical alignment aspect of what we teach. We are building a foundation for the future. The next thing that we need to talk about is the cross curriculum. Students need to understand that when they study a subject, it may have applications to another subject. Mathematics at the university level really is a subject in which you are a service to other departments or colleges within the university atmosphere. There are, of course, universities that offer degrees and majors that are either pure mathematics or applied mathematics, but many times mathematics is just a piece to some other major. A lot of times statistics or calculus are those key kind of service subjects that are what are required for other degrees, and so they need some kind of foundation there. You might also see in some universities that offer them some college algebra courses or some kind of a business math, and so these are serving a purpose in other degrees. But even in the high school or the middle school or the elementary level, math skills are to be developed in students to help them in other areas of their life. If nothing else, to be able to understand their paycheck and how it works, understand medication dosages, understand how things are being represented to them in the media and in politics. These are life skills that you are building for these students. And so we need to help students understand that when they're in math class, they are learning a set of skills, but those skills can carry outside of that mathematics class. And so one immediate application that should be visible to students but doesn't always seem to have the transference that we like is the application of math skills to a science class. And so we use calculations, we use symbols, variables, and modeling in science classes that come directly from the mathematics class, or maybe some variant of that. And so I'm going to give one example of where some of these things come together. we are going to look at slope. So slope from an Algebra 1 perspective is presented as something that's directly associated with a line or a linear function. First, we're going to look at the slope formula. So the slope formula is defined as the variable m equals something. So we have m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So in this function, we have subtraction, we have maybe some basic ideas of an arithmetic sequence because we have a first term and a second term. They have subscripts on them. They're both represented by the same base variable. We have something that deals with equality. We have the idea of a ratio here. And so we have a lot of elementary skills that are built into this. We have some possible middle school or high school level skills built into this. And so this is something that we give to students so that they can use this to find the slope for a line if they're given 2 points. We might advance this a little bit as they move towards the end of Algebra 1 or maybe into an Algebra 2 course, possibly even a pre-calculus course, and we could call this the rate of change formula. Now, rate of change may be a term or a concept that's introduced in an Algebra 1 course, and so that's great if it is, and that students can start to understand that the slope is a term of rate of change, but there are courses that represent this as a separate function. So do students make that transition mentally when they see the new formula? So let's look at rate of change. So this is a formula that might be represented in, say, an Algebra 2 course. And it's said to be a rate of change formula. So some way we have to designate that this is rate of change, capital R, R with the subscript OC. So we have some way of designated this as rate of change. We have function notation in this one. And so we have f of x sub 2 minus f of x sub 1 all being put in relation to the x sub 2, x sub 1. Now the denominators are identical in this, and that's the only thing that's identical in this. Are students making the transition in their mind from the y notation to the function notation? It should be taught to them in an Algebra 1 class as they move from the idea of equations into the idea of functions, that y is replaced with the f of x notation. But are they making this transition mentally? Are they understanding that this new formula that they're being told to memorize is exactly the same formula that they've already memorized from an Algebra 1 perspective? Going into a science curriculum, this may be represented in a different way. We might introduce another term in here, the Greek letter delta, and so we could be showing them another formula. They've already memorized it, but they don't necessarily realize they've memorized it because now we're in a science class, we're not in a math class, we're using a different symbol. So do they realize that if you want to look at some kind of rate of change calculation in a science class, that you have the same formula? So perhaps we just call this R in a science class, and we have delta y over delta x. Do students realize that this is exactly what this is telling them? That there's a change in the y coordinates, there's a change in the x coordinates, and you're setting them in a ratio with each other? And then, as an idea of vertical alignment, do you as teachers realize that you are preparing these students for a basic calculus concept? So we have delta here, which is a Greek D. You have probably seen this with D's in it. There's a couple different versions of this. So the first version that you may have seen with D's in it is this symbol set is the derivative. The derivative of a function is the equation for the slope at every point continuously along a curve. So this uses our notation as a change in y in relation to a change in x, and it is relating back to slope. So we have this dy dx. We also have the partial differential notation where we use a curly d. We could have this partial notation where we make these d's a little more curly, and so we are looking at a partial derivative between two terms. So we get these curly d's, which show us another representation of a ratio, but this is a partial derivative. And so we may have something of this nature as well. This is also talking about a rate of change between two quantities. So this is moving from elementary level skills through middle school, high school, into college level. And we are providing a service through our mathematics because we are preparing students for science classes of a variety of natures. It may be a chemistry class in high school. It may be engineering in college. So an awareness of what we're doing and why we're doing it and what the goals for these students should be something of a focus for us as teachers. We need to be mindful of this, and we need to be working toward student success. That is easier said than done. And sometimes we have to make the extra effort to push extra work towards students that need to build certain skills in which they lack. And so we need to be aware of those things through assessments that we do and looking at what skill sets that students are coming into our class with. We may have an expectation that students have a certain skill set when they come into a class. If we don't do some kind of a pre-test or assessment as they come in, we may not immediately be aware of this until we've gotten partway into the class, and it's hard to kind of make that a natural progression. If we're aware as students come to us, as we do assessments and things like that, then we can build into our curriculum a way to reinforce and build up those foundations where there might be weaknesses. And so we have to be very mindful of, if we're going to be good teachers, we need to be aware of student needs and how to make those students successful, both in our class and in the future. Cheerful Calculations.